peeps, it's Anna here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to be looking at a Natural Sciences Energy and Change Grade 9 question taken from the ECE November 2013 question paper. So let's dive straight in. This is question 4 in that question paper. And in order to answer the questions that are going to follow, we need to do quite a bit of reading to get the background. So let's get straight in. It reads, an experiment was conducted as part of an investigation to establish the influence of the thickness of a conductor on the resistance of the conductor. Okay, experimental procedure. 3 cells, a switch, an ammeter, and a metal conductor were connected in series. A voltmeter was connected in parallel across the conductor. The switch was closed and the readings on the ammeter and voltmeter were noted. Ohm's law was used to calculate the resistance of the conductor. The experiment was then repeated with 2 more metal conductors with different thickness, B and C respectively. Information related to the experiment. Okay, so this is information for conductor A, the first conductor, conductor B, and conductor C. The diameter of the conductors was different. Conductor A was 0.5 millimeters, conductor B was 1 millimeter, and conductor C was 1.5 millimeters thick. Okay, but the type of material was the same, nichrome, for all 3 conductors. The length of the conductors were all the same, and the time taken to note readings after the switch was closed was also kept the same for all 3 conductors in the experiment. Results. The following graph was drawn from the results obtained. It represents the relationship between the thickness of the conductors and their resistances. So if we look at this graph, it shows the relationship between the thickness on the x-axis rather, and the resistance in ohm, and this is given on the y-axis. So when the conductor was 0.5 millimeters thick, the resistance it gave was 3 ohm. When the conductor was 1 millimeter thick, the resistance seen was 2 ohms, and when the conductor was 1.5 millimeters thick, the resistance seen was 1 ohm. Okay, and then the first question says use the information given in the experimental procedure and draw a circuit diagram of the setup and indicate the direction of the current in your diagram. Okay, and then the next part of the question is write down the independent variable in this experiment. Okay, so in the first part, when we read, we were told that the cells, a switch, and an ammeter were connected in series, as well as the conductor, and the voltmeter was connected in parallel to the conductor. Okay, so this is how we came up with this diagram. And the direction of flow is from the cells this way. Okay, so and this is your switch. You can draw it open or closed, but as long as you label it, that's fine. And 4.2 asks us what is the relationship, what is the variable rather, the independent variable in the question. Now the thickness or diameter of the conductor is the independent variable because the other variables remain the same throughout the experiment. Only the thickness or diameter of the conductor is what changed throughout the experiment. Okay, let's have a look at 4.3. It says use the graph and write down the conclusion that can be made related to the relationship between the resistance and the thickness of the conductors. The graph in question is this one here, okay, which we explained or had a look at just a few moments ago. So let's go back. And draw the conclusion that if the thickness of the conductor increases, then the resistance of the conductor will decrease, as we saw from the graph. Okay, 4.4 says you must use Ohm's law, R equals V over I, and calculate the reading on the voltmeter for resistor A. The reading on the ammeter was set up was 1.5 amps. So the formula for Ohm's law, calculating resistance using Ohm's law, is R equals to V over I. Okay, V being the voltage and I being the current measured in amps. So what we want to do here, let's first put values for these as because they are given in there. Okay, 3 came from the graph, the first graph, where we said that when the conductor was 0.5 millimeters, the resistance was 3 ohms. So that's where the 3 came from. So we're saying 3 ohms equals to V over 1.5 A. Now we want to make V the subject of the formula, okay, so that we can answer this question. We want to calculate the reading on the voltmeter for resistor A. So to make the V the subject of the formula, V equals to IR, and to put that in values, it becomes V equals to 3 ohms times 1.5 amps, and therefore the answer for V equals to 4.5 volts. That's the reading on the voltmeter, and that is the answer to our question 4.4. Let's have a look at 4.5. What is the meaning of an ammeter reading of 1.5 amps? Okay, what this means is that 1.5 coulomb of charge passes through the conductor or ammeter in 1 second. We're just explaining what 1.5 A means on an ammeter when you're looking at it. Okay, it's just telling us that 1.5 coulomb of charge is passing through the ammeter per second. Okay, right. 4.6. A second conductor with thickness X is now connected in parallel with conductor C. This additional conductor in parallel will have one of the following two effects, C1 or C2, on your results. Okay, this is C1 and that's C2. Which one of the two effects, C1 or C2, would you consider more likely? Explain your answer. We say that C2 is a more likely outcome because an additional conductor connected in parallel with C will increase the total thickness of the conductors and therefore decrease the resistance. If you remember 4.3, we said that the thickness of the diameter of conductor increases. Sorry, if the thickness of a conductor increases, then the resistance of the conductor will decrease. So if we add an extra conductor, it increases the overall thickness and therefore we have a decrease in the resistance. There we go, and that is the decreased resistance, 0.5 ohms. So that's that for question 4. That was quite a bit to get through, but we can always rewind and replay and replay until it all makes sense. So that's that for question 4. But before I go, I'd love to say a very special thank you to our epic sponsor for making this video possible. You can read about them in the description below. Also, be sure to head over to our website and check out more of these epic tutorial videos. If you can't find the answer to your question, send us your question and we'll respond with a personalized video just for you. Until the next time, stay epic.